In a previous video, we talked about the Taylor polynomial, which is given any Taylor series. If you take the finite or the partial sum of the series, then you get a polynomial, which is called the Taylor polynomial. And we had a relationship that the remainder is always less than or is bounded by this particular approximation. It says approximate this function by a Taylor polynomial of degree 2. Okay, degree 2 means you're only going up to, remember, f of x would be given as f of a plus f prime a over 1 factorial x minus a plus f double prime a x minus a squared over 2 factorial. So that's it. You stop here because that is degree 2. So let's see what we need. We need fx, which is x to the 1/3. We need f prime of x, which is 1/3 x to the negative 2/3. And x second derivative, which is 2/9 x to the negative 5/3. Then we need f of 8, which is cube root of 8, which is 2. We need f prime of 8, which is 1/3 of 1 over 8 to the 2/3, which is 1 over 3 times 1 over 4, which is 1/12. Then we have negative 2/9, 1 over 8 to the 5/3, which is negative 2 over 9, 32, 16, 90, that's negative 1 over 144. So the Taylor polynomial of degree 2 is going to be f of 8 plus f prime of 8 x minus 8 minus f double prime of 8 x minus 8 squared over 2 factorial, which is going to be my approximation for the function of cube root. Another example is, what is the maximum not the minimum, sorry, the maximum error that's possible in using this approximation. So I take just the first 3 terms, and I know x is between -1 and +3. For what value of x is this approximation accurate to within a certain amount? So what's the next term? According to our result, the remainder should be less than m, which can be 1 because it's a trigonometric, or it's a sine series. That's going to be x to the 7 over 7 factorial. Okay, which means it's at max x to the 7, the absolute value, 7 factorial, which comes out to 5040. Now x is between negative 0.3 and positive 0.3. That means the absolute value of x is less than 0.3. So this is going to be less than 0.3 to the 7 over 5040, which comes out to, if you use the calculator, 4.3 into 10 to the power negative 8. So that's the allowable error. Now, for what value is this approximation accurate to within this? Is, again, we want this to be less than 0.00005, which means we want this to be less than, if you multiply, it's that, and then x has to be less than the 7th root of 0.252, which is approximately 0.821. So as long as x is within 0.821, then your error is within your required limits. So with this, we conclude the topics for this semester. What we learned here is that we can not only represent things as power series, we can actually use that to approximate them to however degree of accuracy we want. Okay, that's it.